to this discussion of light as a wave, and we really won't pick up into going back to applying quantum mechanics to the atom until Friday, but in the meantime, we'll really get to understand the wave-particle duality of light and of matter. So we'll start with thinking about some properties of waves that are going to be applicable to all waves that we're talking about, including light waves. The easiest kind of waves for us to picture are ocean waves or water waves, because we can in fact see them, but they have similar properties to all waves. And those properties include that you have this periodic variation of some property. So when we're talking about water waves, the property we're discussing is just the water level. So for example, we have this average level, and then it can go high where we have the peak, or it can go very low. We can also discuss sound waves. So again, it's just the periodic variation of some property. In this case, we're talking about density. So we have high density areas and low density areas. So regardless of the type of wave that we're talking about, there's some common definitions that we want to make sure that we're all able to use. And the first is amplitude. And when we're talking about the amplitude of the wave, we're talking about the deviation from that average level. So if we define the average level as 0, you can have either a positive amplitude or a negative amplitude. So sometimes people get confused when they're solving problems and call the amplitude this distance all the way from the max to the min, but it's only half of that because we're only going back to the average level. So what we really want to talk about here is light waves, and light waves have the same properties as these other kind of waves in that they're the periodic variation of some property. So when we're discussing light waves, what we're talking about is actually light or electromagnetic radiation is what we'll be calling it throughout the course, and that's the periodic variation of an electric field. So instead of having the periodic variation of water or the periodic variation of air density, here we're talking about an electric field. We know what an electric field is. It's just the space through which a Coulomb force operates. And the important thing to think about when you're talking about the fact that it's a periodic variation is if you put a charged particle somewhere into an electric field, it will, of course, go in a certain direction toward the charge it's attracted to. But you need to think about the difference. If you have a particle here on your wave, it will go in one direction. But remember, waves don't just have magnitude. They also do have direction. So if instead you put your particle somewhere down here on the electric field, or on the wave, the electric field will now be in the other direction. So your particle will be pushed the other way. And from physics, you know that, of course, if we have a propagating electric field, we also have a perpendicular magnetic field that's going back and forth. But in terms of worrying about using the concepts of a wave to solve chemistry problems in this course, we can actually put aside the fact and only focus on the electric field part of things, because that's what's going to be interacting with our charged particles, such as our electrons. So other properties of waves that you probably are all familiar with, but I just want to review, is the idea of a wavelength. If we're talking about the wavelength of a wave, we're just talking about the distance that there is between successive maxima. Or, of course, we can also be talking about the distance between successive minima. Basically, we can take any point on the wave, and it's the distance to that same point later on in the wave. So that's what we call one wavelength. We also commonly discuss the frequency of a wave. And the frequency is just the number of cycles that that wave goes through per unit time. So by a cycle, we basically mean how many times we cycle through a complete wavelength. So if something cycles through 5 wavelengths in a single second, we would just say that the frequency of that wave is 5 per second.